When wiring a separate garage with a 125 amp meter main and 4 wires running to the house, the question arises whether to treat the garage as a service entrance or a subpanel. This decision impacts how the grounding and neutral connections are handled. Let's examine both options. Option 1 involves treating the garage as a service entrance. In this scenario, you establish a ground and tie both the neutrals and the grounding electrode system together at the garage. The 4 wires, consisting of 2 hots, a neutral, and a ground, are then run to the house. At the house, the grounding wire is connected to the house's grounding electrode system, and the neutral wires are connected together at the house's main panel. Option 2 considers the garage as a subpanel. Here, the 4th wire, which is the subpanel feed, is isolated in the garage. The neutral wire is connected to the grounding electrode system in the garage. The 3 wires, comprising 2 hots and a neutral, are run to the house. At the house, the neutral wire is connected to the house's main panel. A grounding bar is installed in the house's main panel, and the subpanel feed is connected to it. The preference leans towards treating the new building as a service entrance. This approach is justified for several reasons. Firstly, it ensures proper grounding and bonding of the entire electrical system. Secondly, it provides a clear point of isolation for the house's electrical system from the garage. Thirdly, it simplifies future troubleshooting and maintenance. While the subpanel option may be technically acceptable in some cases, it can potentially lead to confusion and electrical hazards if not implemented correctly. The service entrance approach is generally recommended as the safer and more reliable option. To delve deeper into the reasoning behind this preference, let's further explore the concepts of grounding, bonding, and the National Electrical Code, also known as NEC. Grounding refers to connecting electrical equipment and systems to the earth, providing a path for fault current to flow back to the source, tripping a circuit breaker or fuse, and energizing the circuit. This helps prevent electrical shock hazards. Bonding involves connecting metallic parts of an electrical system to create a low impedance path for fault current. This ensures that all metallic parts are at the same potential, reducing the risk of electric shock. The NEC provides comprehensive guidelines for electrical installations, including grounding and bonding requirements. Adhering to the NEC is crucial for ensuring the safety and reliability of electrical systems. When treating the garage as a service entrance, the grounding electrode system at the garage must comply with NEC requirements. This typically involves installing ground rods connecting to a metallic water pipe or using a concrete encased electrode. The grounding electrode conductor, also known as GEC, connects the grounding electrode system to the service equipment. The size of the GEC is determined by the size of the service entrance conductors, as specified in NEC Table 250.66. The neutral conductor, also known as the grounded conductor, is connected to the grounding electrode system at the service entrance. This connection ensures that the neutral conductor is at or near ground potential. The equipment grounding conductor, also known as EGC, provides a path for fault current from electrical equipment back to the service entrance. The EGC can be a wire, conduit, or other approved metallic path. The EGC must be properly sized and connected to ensure effective fault current protection, as specified in NEC Section 250.118. When treating the garage as a subpanel, the grounding and neutral connections must be handled differently. The neutral conductor is isolated from the grounding electrode system at the subpanel. A separate equipment grounding conductor is run from the subpanel back to the main panel in the house. This ensures that fault current has a dedicated path back to the source, preventing it from flowing through the neutral conductor. The size of the equipment grounding conductor is determined by the size of the overcurrent protection device protecting the subpanel feeder, as specified in NEC Table 250.122. It's crucial to understand that the neutral conductor and the equipment grounding conductor must be kept separate in a subpanel. Connecting them together can create a parallel path for neutral current, which can lead to overheating and potentially dangerous conditions. NEC Section 250.32 addresses the grounding requirements for buildings, such as detached garages. It specifies the conditions under which the grounding electrode system at the outbuilding must be connected to the grounding electrode system at the main building. In general, if the outbuilding is supplied by a feeder that includes an equipment grounding conductor, the grounding electrode system at the outbuilding must be connected to the grounding electrode system at the main building. This connection ensures that both buildings are at the same ground potential, reducing the risk of electric shock. However, if the outbuilding is supplied by a feeder that does not include an equipment grounding conductor, a separate grounding electrode system must be installed at the outbuilding. In this case, the neutral conductor must not be connected to the grounding electrode system at the outbuilding. Instead, a separate equipment grounding conductor must be run from the outbuilding back to the main building. The decision of whether to treat the garage as a service entrance or a subpanel depends on various factors, including the size of the garage, the electrical load requirements, and the local electrical codes. In some cases, the local electrical inspector may have specific requirements that must be followed. It's always recommended to consult with a qualified electrician to determine the best approach for your specific situation. They can assess your electrical needs, review the local codes, and ensure that the installation is safe and compliant. Regardless of whether you choose to treat the garage as a service entrance or a subpanel, it's essential to follow all applicable electrical codes and safety practices. Improper wiring can create serious electrical hazards, including electric shock, fire, and equipment damage. Always use approved materials and methods, and double-check all connections before energizing the circuit. Furthermore, it is always important to consider future needs and expansion when planning the electrical system for a detached garage. Installing a larger service entrance or subpanel than initially required can provide flexibility for future additions, such as a workshop, electric vehicle charging station, or other power-hungry equipment. Considering the long-term needs can save time and money in the future. In summary, when wiring a detached garage, the decision of whether to treat it as a service entrance or a subpanel depends on various factors. While the subpanel option may seem simpler in some cases, the service entrance approach generally offers better grounding, bonding, and safety. Always consult with a qualified electrician to determine the best approach for your specific situation and ensure compliance with all applicable electrical codes and safety practices. Remember that electrical work can be dangerous and should only be performed by qualified individuals. Understanding the principles of grounding, bonding, and the NEC is crucial for ensuring the safety and reliability of electrical systems. By following these guidelines, you can ensure that your detached garage is wired safely and properly. Let's further clarify the differences between the two approaches. When the garage is treated as a service entrance, the grounding electrode system, neutral, and grounding wires are all bonded together. This creates a single point of grounding for the entire electrical system, which can simplify troubleshooting and maintenance. It also provides a more robust grounding system, which can help protect against electrical surges and lightning strikes. However, treating the garage as a service entrance may require more extensive wiring and equipment, which can increase the cost of the installation. It may also require additional inspections and permits from the local electrical inspector. When the garage is treated as a subpanel, the neutral and grounding wires are kept separate. This is because the neutral conductor carries current under normal operating conditions, while the grounding conductor only carries current during a fault. Connecting the neutral and grounding wires together in a subpanel can create a parallel path for neutral current, which can lead to overheating and potentially dangerous conditions. Treating the garage as a subpanel may be simpler and less expensive than treating it as a service entrance. It may also require fewer inspections and permits. However, it's crucial to ensure that the neutral and grounding wires are properly separated and that the equipment grounding conductor is properly sized and connected. In addition to the grounding and bonding requirements, there are other electrical code considerations to keep in mind when wiring a detached garage. These include the sizing of the service entrance conductors or subpanel feeder conductors, the overcurrent protection requirements, and the wiring methods allowed. The size of the service entrance conductors or subpanel feeder conductors is determined by the electrical load requirements of the garage. The load calculation must include all of the lights, receptacles, and equipment that will be used in the garage. The overcurrent protection devices, such as circuit breakers or fuses, must be sized to protect the conductors from overload and short-circuit conditions. The wiring methods allowed depend on the type of construction and the location of the wiring. Common wiring methods include non-metallic sheath cable, also known as Romex, conduit, and underground feeder cable. All electrical work must be performed in accordance with the NEC and any applicable local codes. It's always recommended to consult with a qualified electrician to ensure that the installation is safe and compliant. They can help you with the load calculation, conductor sizing, overcurrent protection, and wiring methods. They can also ensure that the grounding and bonding requirements are properly met. Remember that electrical work can be dangerous and should only be performed by qualified individuals. By following the electrical codes and safety practices, you can ensure that your detached garage is wired safely and properly. In addition to the technical aspects of wiring a detached garage, it's also important to consider the aesthetics. The wiring should be neat and organized, and all exposed wiring should be protected from damage. The location of the receptacles and switches should be convenient and accessible. The lighting should be adequate for the intended use of the garage. By paying attention to the details, you can create a detached garage that is both functional and aesthetically pleasing. Finally, it's important to document all of the electrical work that is performed. This documentation should include a wiring diagram, a list of materials used, and the date of the installation. This documentation can be helpful for future maintenance and troubleshooting. It can also be required by the local electrical inspector. By keeping accurate records, you can ensure that your electrical system is properly maintained and that it complies with all applicable codes and regulations. In conclusion, wiring a detached garage involves several important considerations. The decision of whether to treat it as a service entrance or a subpanel depends on various factors. It's crucial to follow all applicable electrical codes and safety practices. And it's always recommended to consult with a qualified electrician to ensure that the installation is safe and compliant. Remember that electrical work can be dangerous and should only be performed by qualified individuals.